Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Satellite Communication, and today's lecture topic is Primary Power from Unit 2 Space Segment. On completion, the students will be able to understand the possible sources of power supply for a satellite, write down about cylindrical satellites, and determine the expression for total power requirement. Primary power. To provide primary power supply for a satellite, there are two possible sources available. They are nuclear supplies and solar supplies. Nuclear primary power systems, where the solar energy is weak, such as for deep space missions, nuclear supplies are being employed. There are two types of nuclear primary power systems. They are type 1 nuclear reactor type and type 2 thermoelectric generator type. In type 1 nuclear reactor type, there is a boiler with a working fluid such as mercury. This boiler is heated by a small nuclear reactor and vapor is produced. The vapor is used to drive a turbine alternator. In type 2 thermoelectric generator, this is commonly used type for smaller power supplies. It has a single radioisotope thermoelectric generator. Solar primary power systems. Solar cells. The solar cells produce power, but individual cells can generate only small amounts of power. Therefore, large number of solar cells should be arranged in series parallel connection, which is called as the solar panels. Cylindrical satellites. Cylindrical type satellites have two panels, namely outer panel and telescope panel. Solar cells are arranged around these panels or drums. During launch, only the outer panel is exposed to sunlight. After reaching the final orbit, both the panels generate electrical power. Solar cell type satellites. In this type of satellite, to achieve high power, solar panels are arranged in a form known as rectangular solar sails. These solar sails are folded during launch phase of the satellite, and after reaching the final orbit, they are extended and are fully exposed to sunlight. Service during satellite eclipse. A geostationary satellite is eclipsed by the Earth twice a year during spring and autumnal equinoxes. The maximum duration of an eclipse is 72 minutes. Therefore, to operate the satellites during this eclipse period, storage batteries must be provided. Examples of such storage batteries in use are nickel cadmium batteries as well as nickel hydrogen batteries. The following diagram represents the block diagram of a solar power system. The total power requirement is comprised of the total transmitter's power, receiver power, housekeeping power, and battery service power during eclipse. Total transmitter power is given as PT is equivalent to the summation of Ni, where I ranges from 1 to n, Pi by eta I, where n is the number of ith type transmitters, Pi is the R of transmitted power, and eta I is the efficiency. Total transponder power is a combination of receiver power as well as the transmitter power. Here receiver power is being added with the total transmitter power. Housekeeping power. This housekeeping power includes the power for the telemetry, tracking and command subsystem, altitude control as well as propulsion. Battery power. The power provided by batteries during eclipse period is the battery power. Total primary power. The total primary power is comprised of all the combination of all the above powers, and here including all the estimated power, the total primary power that must be provided by the solar array is given as P is equal to K PT plus PH plus PE, where K is the design margin factor. Quiz questions on primary power. List the two possible sources to provide primary power supply for a satellite. Give some examples of solar batteries being used to operate satellites during eclipse. Give the equation for obtaining total primary power of a satellite. Thank you.